This question is about integration. Use the substitution u equals cos x to show that the integral from 0 to pi of sine 2x e to the power of 2 cos x dx equals the integral from minus 1 to 1 of 2u e to the 2u du, 4 marks. So if u equals cos x, du dx is minus sine x, that's from MF19, and you can rearrange to get dx, which is du over minus sine x. And if you look at the terminals, the x equals 0, x equals pi, you can transform. When x is 0, u is cos 0, which is 1. When the x is pi, u is cos pi, which is minus 1. So we have everything we need. We can substitute. We replace the 0 with 1. So here 0 becomes 1. And the pi becomes minus 1. And the cos x becomes u. And the dx becomes du over minus sine x. So here we still have sine 2x, sine x, so we still have something in x, so we cannot integrate because we have x and u. So we have to do something so that we can cancel out the x basically. So in the MF19 we have the sine double angle formula. Sine is equal to 2 sine cos. So we use that double angle formula so that we can cancel out the sine x. So we have only minus 2 cos x, but cos x is again u, so we replace the cos x with u. Now everything is in u. This is ready to be integrated. So just pull out the minus out of the integration. So we have minus this guy here, and if you wanna multiply with the integration here, so you can flip the terminals upside down because of this negative. So negative from the integral from 1 to minus 1, or positive the integral from minus 1 to 1. So you replace this negative by flipping the terminals, and that's what we need to prove for part 1. Now part 2, hence find the exact value of. So previously in part 1 we know that we can use this substitution. So now we have to integrate this guy here, and we gotta use the integration by parts. So this is the MF19 formula. It's in this form, in simplest form, but as you can see we are already using u in the first part. So to make things not complicated, let's just use ADB instead. So instead of u, use a, instead of v, use b. Integral ADB equals AB integral minus integral b dA. So the a in this case is the 2u, so this is the a. So if the a is 2u, dA du, the derivative of a with respect to u is just 2, which means the dA is 2 du. And the dB is this whole thing. This is the dB. So if the dB is 2e to the u du, we of course integrate both sides. The integral of just nothing, or 1 dB, is just like the integral of 1 dx, so it's just x, so in this case just b. And the integral here is just exactly the same but divided by 2 because of the chain rule. So now we are ready to use integration by parts. AB, so the a is 2u, this is a, this is b, this is b, this is dA. AB minus integral b dA. Again, the dA is 2 du. So we can cancel out the 2, we can cancel out the 2, and then we integrate e to the 2u du again. So again, we could do same concept here, e to the 2u divided by 2, and then we plug in 1, replace the u with 1, and then we replace the u with minus 1, and then so this is just e squared, and this is just e squared over 2, and this is minus e to the power of minus 2, and this is minus 1/2 e to the power of minus 2. 1 minus 1/2 is 1/2, minus 1 minus 1/2 is minus 3/2, and we can just leave it like this, so or like this in the simplest form. This is okay, or this is the same as e squared over 2 plus 3 over 2e squared, because minus means 1 over, so you can multiply both parts with e squared over e squared here, so we get e to the 4th over 2e squared. We have a common denominator. The final answer in the simplest form would be e to the power of 4 plus 3 all over 2e squared. Alright, I'll see you again next time.